Hello my dear students. So I welcome back to NEET World. So today we will be discussing numericals on chemical kinetics topic. So we will discuss the PYQs of NEET, JEE and EAPCET from this particular chapter. Okay. So let us begin this session with our first question here. The rate constant of a reaction A to B is given as 0.6 into 10 power minus 3 mole liter inverse second inverse. If the concentration of A is 5 molar, then concentration of B after 20 minutes. So how we are going to do this question? See, first of all we need to identify what is the order of this reaction by looking at this rate constant. See, the rate constant they have given as 0.6 into 10 power minus 3 0.6 into 10 power minus 3 mole liter inverse second inverse. Now, by looking at the units of this rate constant K, you need to identify what is the order of this reaction so that you can do this question very easily. Okay, so just look at these values. So what is the rate constant formula I have given as a mnemonic or as a short form, that you just take this concentration power 1 minus n time inverse. This will be the generalized formula for finding what? The units of rate constant for any order reaction. Let us say that n represent nth order reaction. If it is zero order reaction, what we are going to get? Concentration power 1 minus 0 into time inverse. Okay, so we are going to get concentration, that is molarity, that is mole per liter into time inverse. So this will be the units of zero order reaction. Like this you need to substitute n value and you need to get the units of this rate constant, so that you can able to identify what is the order of this reaction. That is the first step you need to do here. Okay, so now you got these units and check here, both units are same only now. So time inverse they have taken in terms of seconds, so second inverse will be your unit here, mole liter inverse second inverse. So what is the order of this reaction? It is zero order reaction. This is the first step that you need to do here. Okay, so after doing this, for a zero order reaction, so what they are asking, the concentration of B, for example A gives rise to B, means let us say I have initial concentrated at the beginning of this reaction as A and this is 0. After some time t, what happens? Sum of this A converts into B now, so X amount is converted from A to B. Okay, so now A minus X is the remaining concentration of A and X is the concentration of B. Okay, they are asking about value of X here. So it is very simple. So just use this integral equation. What is that integral equation we have did? So like this. So just you need to use this K naught equals to X by T. This is the simplest formula you can use. From this you will get for this zero order reaction. Now how I got this equation? So I already discussed while doing the discussion on zero order reaction, first order, second order reactions, which I have made almost 5 series of videos on all the important topics here from the chemical kinetics. Okay, so how do you take? So rate equals to change in concentration dA by dt, okay, which is equals to K naught into A power 0. So A power 0, something power 0 is what? 1, right? So that will become 1. So minus dA equals to K naught dt. Okay, just integrate this equation. So just integrate this equation from A at a time t equals to 0 and A minus X at a time t equals to t. Okay, like this. So that you will get, so here what you are going to get? Here you are going to get A minus of A minus X equals to K naught t. This will be the integral equation. From this, plus A minus A is removed, so X will be equals to K naught t. That's it. This is your integral equation I am using here. So I want X now, so just use K naught into t. That will be your answer. See, K naught is how much given? So K naught is rate constant, is given as 6 into 10 power minus 4. I can write it. Okay, yeah. So what is the units of that rate constant? See, I am writing X equals to 6 into 10 power minus 4. Look at the units: mole liter inverse second inverse. It is second inverse, and time is given as 20 minutes. Directly you don't take just 20 here, just take, it is in minutes now, so multiply with 60 seconds. okay, because our rate constant in second, so our time should be also in seconds, therefore this second inverse and second is removed, therefore you will get the units as mole per liter, which is a unit of concentration. Right now see here 2 zeros are there, so 10 power 2, 10 power minus 4, so it will become 10 power minus 2 here, okay. So x will be how much now? So 36 into 2, so you are going to get 72 into 10 power minus 2 mole per liter, okay. This will be your unit, okay. So just look at the units, where do we have this kind of answer? See, I can write this as 0.72 molarity, mole per liter I can write as molar solution. So 0.72 will be your answer, and option number 3 will be your perfect answer for this question, okay. So this is previous year question, very important I think. I hope you got how we did this question. Yes, if it is clear, yes, you can mention it is clear sir in the comment box, okay. Yes, let us move forward with one more question. Yeah, so look at here, we need to write the chemical rate expression for this particular reaction. Very important, again this model questions also for NEET, JEE and EAPCET, okay. So just look at here, very easy. These are the reactants now and this is product. During the reaction what happens? At the beginning of the reaction, at the beginning, it means time is 0 at that time. So what we have? Only reactants will be have as a starting materials, no product formation at that time, okay. So after some time t, what happens? Some of this reactant will combine and form this product. It means during the reaction, concentration of reactant decreases, concentration of product increases. Right now this is what the basic fundamental thing we know, okay. Now look at the stoichiometric coefficients first, okay. So if you look at the stoichiometric coefficient, it is 132. So write this equation. So rate is equals to these are reactants now, so change in concentration of N2, like N2 is there na, take change in concentration of N2, that is dN2 by dt, okay. Since I told it is a reactant, so concentration decreases now, so put that negative sign here to indicate decrease in concentration of reactant. That will be equals to next change in concentration of H2 dH2 by dt I am writing, okay, with minus symbol. And what about its stoichiometric coefficient? It is 3, here it is 1, so you can write here 1 by 1, that is same only, and here should be written as 1 by 3. So whatever the stoichiometry is there, that take here in the denominator. And what I told you, for reactant concentration decreases now, so you should take minus here, okay. And this will be equals to what is the product then we have here? It is change in concentration of NH3 dNH3 by dt, okay. What about the stoichiometric coefficient here? 2 now, so write it as 1 by 2. Now what happens during the reaction? Concentration of product increases now, so write it as plus indicates what? Concentration of product is increasing, that's it, okay. So from this, so look at this, from this identify the correct match out of this 4. So if you look, so minus dN2 by dt is equals to 1 by 2 d ammonia by dt. So this is perfect answer, and other options you can cross verify. See, they are saying 1 by 3, see 1 by 3 dH2 by dt, that is fine, okay. But here for ammonia it is a product, that should be positive sign, but here they mentioned a negative sign. It means this is incorrect. Like this, very simple one now, very simple, right now. Yeah, so again it is a previous year question. Now for your practice purpose, I just wanted to mention here one reaction. So just write its rate expression. For example, I have 2A, I have something like 2A, I have 2A plus 3B giving rise to 2C plus 4D. So write its rate expression like this, like whatever the way I have represented, try to do it for this. Very important. There are many times questions asked on this, and even other model questions which are related to this I have solved during our discussion of the class, okay. You can watch it, okay. Next, here we have addition of catalyst, the effect of catalyst. It means the addition of catalyst during a chemical reaction alters which of the following quantities. So tell me which of the following is altered. See, For example, here we have a reaction coordinates like this. So what happens, we will be having activation energy here, let us say, energy coordinate this is, okay. So what happens during the reaction, we will be seeing this kind of energy profile diagrams. Now let us say this is in absence of catalyst, okay. So now in presence of positive catalyst, what happens is means the path, it will create a new path, new reaction pathway like this. See now what happens to its energy, is in this case energy is reduced right now. So what it is doing, it is decreasing the activation energy, it is providing a new reaction pathway with lower activation energy. It decreases the activation energy. What it will do, it will alter the activation energy. If it is positive catalyst, it will decreases. If it is negative catalyst, it will increases this activation energy by providing a longer pathway, reaction pathway. You can understand like this. So option 2 will be your perfect answer. Very easy it is also. Next, here again look at here, a mechanism of hypothetical reaction is given like this, okay. So you need to write the order of this reaction. So always remember, order of the reaction should be taken with respect to reactants, right, that is one thing. And order of a reaction always determined from slowest step, okay. It means this is the slowest step, so rate law should be written as so how can I write rate law? So rate of this reaction is equals to K into concentration of X and concentration of Y2, okay. But if you observe, the reaction is starting with X2 and Y2, these are the reactants. But here in the slowest step, what is the species involved? It is X, it is not X2. X2 is the reactant, X is not a reactant, it is an intermediate. So always remember, in this rate law, this intermediate should not be involved. It means we should remove this intermediate from here and we should take it in terms of X2 so that it will become correct. So how can I make it? See, in order to remove this, look at this first equation. So this is 1, 2 and 3 I am saying. So by looking at this first equation from 1, what I can write? So I can write for first this reaction, let us say K1 is the equilibrium constant. K1 is equals to concentration of product, like X and X is there now, concentration of this X and this X, it will become X square right now. So X square by X2 I am writing, okay. We can write it like this now. So after this, the X square will be written as K1 into X2 right now. So from this I want only X, it means X equals to root over K1 into X2. So I got an equation in terms of reactant X2 and this is already Y2. So just replace this X by this equation. So that we will get rate is equals to K into, K is the actual rate constant here, and in the place of X I can write it as root over K1 into root over concentration of X2 into, this is done, and here we have concentration of Y2. Like this we should write, okay. What they are asking, overall order of the reaction will be very easy. It is, see, K is a rate constant and this K1 is also a constant, okay. So both are multiplying, so I am writing it as a new constant like K dash, okay. We will get some value that is considered as K dash, and x2 power root we have now, that I can write 1 by 2, and concentration of Y2 power 1 here we have. What is the total order? So for X2, with respect to X2 it is half, with respect to Y2 it is 1. So overall order will be what? These are the individual orders we have for reactant X2 and Y2. This is the actual rate law we should express for this particular reaction. This is the main reaction now. So these are the starting reactants. We should always express our rate law for this starting materials, reactants only, okay. If any intermediates are involved, that should be eliminated, okay, that should be removed using the other steps, okay. Yes, now you have order, individual order with respect to X2 and Y2 are half plus like half and 1 right now. So sum of them will be 3 by 2, right? So 3 by 2 I can write 1.5. What is the overall order of this reaction? It is 1.5. So third option will be your perfect answer for this question. Hope it is clear right now. Yes, if it is clear, just click on the like button. Okay guys, I hope you are really enjoying this session. If it is so you just share with your friends, they can also learn something new from this. Okay, if you feel benefited, you can share with them. Okay, next, here we have one more question. When initial concentration of reactant is double, the half-life period of a zero order reaction will be. So what happens if initial concentration is changed? So look at here. So for zero order reaction, just now I given an integral equation. What is that integral equation? So I just mentioned K naught equals to x by t. This is the first question I think so in this session we have taken, and we have derived for integral equation of this expression of this zero order reaction, something like this. So x represent amount of product formed right now. So now in order to complete this reaction, see, when initial concentration of reactant is doubled, half-life of the reaction, it means I want this in terms of T half. So T half I can write x by T now. So here in the place of x, what I should say, when T approaches half, it means the time required for completion of half of the reaction. Let us say at a time T, A is the initial concentration of reactant. So T half means what? The time required to complete half of the reaction. It means concentration of that reactant should become half. It means it should become A by 2. Okay. So whenever I want to write this T half, I should remove this x and I can write it as A by 2. Okay. And here K naught, like this we can write. So this is the half-life of the zero order reaction. Very, very important. So from this, what we have got here? T half is directly proportional to A, concentration, initial concentration of reactant, directly proportional to A. So now look at here, when initial concentration of reactant is doubled, if this is doubled, okay, now what happens to T half? So it will, if it is doubled, it will become 2A. Okay, if it is becoming 2A, so this will also becomes what? It is also becomes double, not 2 T half it will become right now. So if it is multiplied by 2, this is also multiplied right now, so that I can say if that is double, this is also doubles. Okay, so that because they are directly proportional, so you can say second option will be your perfect answer for this question. Okay, yes, let us move forward. Yeah, so here one more question I have. If the rate constant for a first order reaction is K, the time required for completion of 99%. So how can you do this for 99%? If the rate constant of first order reaction is K, the time required for completion of 99%. So what is the equation we have? T equals to 2.303 by K. This is the integral equation for first order reaction, integral rate equation for first order equation. Okay, if you are not aware of this, just watch the previous sessions of this chemical kinetics from this like playlist, so that you will get clarity over this topic. Okay, 2.303 by K log A by A minus X. This is the formula we should use. Okay, they are saying 99% of the reaction, if A giving rise to some product B, okay, A is the initial concentration, this will be 0. After some time T, so the remaining concentration will be A minus X for this reactant, and X will be the concentration of this product B. Okay, so now 99% of reaction is completed. It means X is 99% is completed. So here 100 minus X, only 1 is there. So I can say T equals to 2.303 by K log. So initial concentration, if A is equals to 100. Okay, so I am taking 100. So 100 minus 99 is how much? 1 now. So take that 1 here. That's it. Okay, so what you are going to get from here? Very easy now. How easy this question is? All questions which I discussed are previous year questions only. So T 99% equals to 2.303 by K. Okay, log 100 means I can write 100 as 10 power 2. So log 10 power 2 if I write. So what happens to this? So I can write it as 2.303 by k. So I can write this exponential term here 2 log 10. So log 10 is 1 right now. So you have an answer of 2.303 into 2 by k. So I can write it as 4.606 by k will be your T99%. Okay, yes. So this will be your answer. So where do we have 4.606 by k? So your third option will be perfect answer for this question, right? Hope it is clear. Right. Let us move forward with few more questions. Yes, guys, those who are in live or those who are also watches this after the recording of this live session, so you can also write in the comment box that like if any doubts are there, any specific topic to be discussed, or anywhere you are getting confused here, you feel free to ask in the comment box or chat box. We will definitely help with that. Okay, yes. And you can join our Telegram group where we are going to share all these PPTs, or you can also have one-on-one interaction with your faculties and all. Okay, you can post your doubts there. Okay, some of our team members may respond to that based on their time availability. Okay, so you feel free to ask anything in the chat box and in the Telegram group by joining through the link which is provided in the description box. Okay, yes. Next we have one more question here. Yes, look at this question. So try to answer that. Try to answer this. The slope of Arrhenius plot log k versus 1 by t for first order reaction is this much. Okay, this much. The value of EA, activation energy of the reaction, is, choose the correct option from your answers from these 4 options. How do you do? So log k, so from where we will get Arrhenius plot they are saying now. What is that Arrhenius equation? K is equals to A into e power minus EA by RT. Right now, where EA is activation energy and R is universal gas constant, T is absolute temperature, and A is pre-exponential factor, K is rate constant. Okay, for first order reaction, so it will be K1, that's it. Okay, and units of K and A will be same. You just watch the previous live session yesterday's where I have discussed about Arrhenius equation. Okay, few questions also discussed there. If you are not aware, you can watch it. I am going to explain this now. Yes, so now they are saying ln K versus 1 by T. So how can I make? So I am sending this here, K by A is equals to e power minus EA by RT. Okay, this is the Arrhenius equation. From that I have written this. So I am sending E to this side. So it will become ln K by A, which is equals to minus EA by R into 1 by T. Okay, these EA by R I have written separately. Now look at here, they are saying ln K versus 1 by T. It means here log A by B form it is now. Log if it is ln of A by B, how can we write? ln A minus ln B. So similarly here ln K minus ln A is equals to minus EA by R into 1 by T, like this. So after this I want only for ln K. So ln K will be equals to minus EA by R into 1 by T, which is equals to, if I send that side, it will become plus ln A. So if you observe this ln K versus 1 by T now, so y equals to mx plus c type of graph you are going to get, and slope you have in terms of negative, minus EA by R you have. So how is your slope? It should be negative and intercept should be positive. Yesterday only we discussed this kind of things right now. So now here ln K and here 1 by T slope. So 1 by T is your x on x axis I am taking. So slope is negative. So it should be something like this. Okay, and here see what is the intercept? This is the intercept of ln A. Here you can take, and slope m will be how much? Minus EA by R. Okay, so this is what we got from this equation. So now EA by R is our slope. They are asking us to calculate activation energy from this. So why I have explained all these things? Because next question which I am going to give you as a homework, that will be similar to this only. That's why I have explained all these things. Okay, so now how much value for the slope? See, they mentioned for the slope, the first order reaction with slope of minus 5 into 10 power 3 Kelvin. So this is minus EA by R will be equals to minus 5 into 10 power 3 Kelvin here. Okay, like this I can write. So this minus is removed. So EA will be how much? 5 into 10 power 3 into R value. See, our answer should be in kilojoules. So R, universal gas constant value, also they mentioned it as 8.314. Take here 8.314 joule Kelvin inverse mole inverse. Okay, here also Kelvin. So Kelvin inverse is removed, so that you have something like, see, 8.3 means I can say 4, so 2, okay, and 40, so around 42. Okay, so here you are going to get how much? 5 is a 15 now, so 41.5 into 10 power 3 joule per mole. Okay, so 10 power 3 I can write kilojoule now, so kilojoule per mole, that is 41.5. Okay, so EA will be this much. So where do we have? So fourth option will be your perfect answer for this question. Okay, yes. If everything is clear, so just click on the like button. Yeah. Next, we have, I will be showing you that question, wait. Yeah. So look at this. So look at this same question now. See, ln k versus 1 by t. What is a perfect graph? The exact graph that corresponds to ln k versus 1 by t. So this is again a question in NEET 2024. See, repeatedly they are asking similar questions. The concept will always same, but they will modify the way of asking question. See, the previous question which I have explained, based on that only it will be, again that is a PYQ, again it is also PYQ, right? So you should be clear with what? All the topics, I mean concept first, okay? Once you are clear with the concept, then you start doing the numericals. Do not directly go to the numericals and don't get demotivated. Always try to be clear with the concept first. First do only very basic questions. Do not be hurry with the PYQs directly. Okay, do some very basic question. Whoever the teacher teaches you, take the questions, basic questions from them. I think they will be definitely giving few questions while doing in the class itself right now. So do those questions once again. After that you go to the other your textbook modules, whatever the materials you have, you go through that. Then you go to these PYQ sessions. Okay, yes. Okay, yeah. So now if you are new to this channel, please subscribe to the channel first. So if you are very new to the channel, just subscribe the channel first. Yeah, and also click on the like button so that it will be shared to the more number of students. So more the number of likes, more will be the shares, like that it will be. Okay, yeah. So let me give one more homework question. This will be the question that you wanted to do once. Just give an answer for this in the chat box. Yes, and this question I have explained during our discussion of first order reaction in the class. Okay, so now I am giving this same question for you. Try to solve this question, and if you are really facing difficulty to answer this, you should watch the chemical kinetics series videos which I have made. In that I have discussed this, okay, during the first order reaction. I think that is chemical kinetics part 3. So in that video I have discussed about this question. So just try to answer this. If you are unable to answer, then only you can go and watch it. Okay, so thanks for watching. If you have any doubts, so feel free to ask me in the chat box. I am looking into it. Feel free to ask. Yes, any doubts, anyone? Sri Akriti from next toppers, and the next Ayush. Anyone in the chat box? Yeah. So if no doubts, we'll wind up with this session and we'll meet again in the evening live session So where I am going to discuss about the some basic concepts of chemistry. Okay, it's a live session, again you can join it evening. Okay, and stay connected with this. Every day we will be coming up with important numericals from all the chapters. Okay, yes, thank you.